Thank you, Mr. Chairman.
Sorry.
I am here on behalf of my colleague, Todd Bilby, who is a colleague from the US. He could not come to the conference and asked me to present it. And this is a very large study from the US on the reproduction performance of dairy heifers in 2 Estrus detection systems and treated with 2 prostaglandin formulations. And it's done in the University of Florida. And I appreciate the endurance that you have at the end of the conference to be here and to listen to this interesting study. In heifer raising, we aim for calving at around 24 months of age. And we aim for around 640 kilos at calving and 560 after calving, and more or less, as I said, 24 months. And also, we need to make sure that if these heifers calve, that the variation around 24 months is limited. And this variation needs to be limited because if you go longer than 24 months, it costs too much milk, and if you go too much below 24, below 22 months, it costs milk also because the animals are too small and it affects lifetime production. And to decrease that variation, on many farms, prostaglandins are used. And the simplest form of prostaglandin use is 2 injections of prostaglandin with 14 days interval. If you work on a large dairy in the US, the question sometimes pops up, which prostaglandins do I need to use? And then you need to have an evidence-based opinion on what to do, which products to advise. And we compared Dinoprost and cloprostanol because they are frequently used in the US, and they are different molecules. The Dinoprost has a half-life of 9 minutes, and the cloprostanol has a much longer half-life of 3 hours. And we were looking for an evidence-based advice on what to advise in heifer raising. Why do we use heifers and not older cows in this trial? Because cloprostanol was shown by these 2 authors to improve pregnancy rate compared to Dinoprost only in heifers. And nobody has ever shown a difference between these 2 molecules in older cows. And there was also one author that did not show a difference. So the literature on the difference of these 2 products is not conclusive. But if 2 out of 3 papers show a difference in heifers, your odds of finding a difference is bigger in heifers, and that is why we choose to find a difference in heifers. There was also, it's not clear why we see this difference in heifers and not in older cows. The hypothesis is that the dry matter intake in heifers is lower, and therefore the progesterone metabolism could be slower, and therefore the impact of prostaglandins could be different. The hypothesis of the trial was that the longer half-life of cloprostanol could result in a faster and more thorough luteolysis, and that could be of influence in pregnancy in heifers. And if you want to show those effects and those differences, there's one big confounder, and that is the estrus detection. Because if the estrus detection is not right, then you can never really show that difference. And therefore, we also included in the trial 2 detection systems, a visual system with tail paint, and this is the tail paint capsule that is often used in the US, and an automatic detection system. And these systems are more frequently used in the US, increasingly used. And that is a sensor on the leg or a collar around the neck with a sensor in it too. And they detect rumination and activity. Objective number 1 was to evaluate the reproductive performance of dairy heifers treated with cloprostanol versus Dinoprost. We also, this is the one part of a trial. The other part of the trial is a very big trial. Was looking towards estrus characteristics of these two products, and that was a poster yesterday. So we also looked at that, but this trial will focus on the reproductive performance. Objective number 2 was to look at those detection devices, automatic versus visual, and to see what influence they had on reproductive performance and how they interacted with these two prostaglandins. The study design, it was a large trial using over 1,000 heifers, 505 in one group and 490 in the other group, randomly assigned. It was on one farm, and we also took blood samples of 91 cows to detect progesterone and estradiol levels. And it was randomized design, 2x2 factorial, so you could also study the interaction between the prostaglandin and the estrus detection device. So what you do is you start at an age of 372 days and a body weight of over 340 kilograms, and then you assign heifers to the first prostaglandin treatment, randomly assigned. If they come in heat in this period, you inseminate them, and if they don't come in heat within 14 days, you re-inject. And if they then come in heat, you inseminate them again. We also used embryo transfer, so this was done quite quickly, and this was done 6 to 9 days after the estrus was detected. Then at 28 days, the automatic detection device was removed, and at 35 and 75 days, pregnancy checks were done. And an animal was pregnant if it was both detected as pregnant at day 35 and day 75, and pregnancy loss was pregnant at day 35 and not pregnant at day 75. And during this whole period, the estrus detection devices and breeding was based on automatic versus visual, and they were also randomly designed. So here you have again a picture of this collar with the sensor, and here you see a cow with the collar around the neck. And this is a data flow system from SCR in Netanya from Israel, and it basically measures, this is activity, this is rumination, and it detects activity here in a 2-hour interval, and then it compares that 2-hour interval with the average of the last 7 days. And then you see a peak, and that usually detects the estrus. And at the same time, you see a nadir here in the rumination. And if that occurs, you have a good indication that the cow is in heat. And that is shown in the software system. If you here you have cow 42178. It's 19 days from the last cycle. It has an activity peak of 100. That means that's the maximum activity. It has a rumination nadir of minus 48. So that's quite low. You see it going down. And a heat index, which is an algorithm of both activity and rumination, of almost 100. So this shows the cow is in heat and needs to be bred in a time window of 17 hours from that moment. What were the results? I'm not going into the statistics for the sake of time, but very appropriate statistical methods were used. First, as I said, we took blood samples and compared the two progesterone prostaglandins, and we see at the time of treatment there is no difference, and this is also what you would expect. No difference between the progesterone level for both products. And then at estrus, there was a significant difference between cloprostanol and dinoprost. And this looks impressive, but it is not so impressive because still this is the dinoprost is 0.11, and this is already quite low. This is lower, but it probably has no implication, is not so relevant because these concentrations are only related to pregnancy if they are bigger than 0.5, and here we are around 0.10. So that is why we also measured estradiol level at estrus, and you see no difference. And this is more important because this shows that the quality of the estrus is not different, and that this difference in progesterone between the two products is not so relevant. This is the result of this is the Heifers not serviced. That means that if the lower the line, the more Heifers are serviced. And this is the days since the first prostaglandin treatment. And you see the blue line is lower than the red line, means that the cloprostanol cows came in heat at 4.5 days on the mean and 3 days in the median. And the dinoprost almost came a half a day later in the mean, and the median was the same. But you see here there is a half a day difference, and that's what you see here, that if you treat with cloprostanol, cows come in heat earlier, and this difference was significant. There is this difference in practical difference between these two products. Then we looked at the interval first to second service, and again you see the automatic detection device here has a lower line showing that the time between first and second service is shorter. The 0.8 day here is the mean, which is almost 1 day. That means that if you detect automatically, you detect estrus 1 day earlier. And that is quite a striking difference. The same is for pregnancy. You see with the automatic detection device, pregnancy is better. The lower line is a higher pregnancy, and that is with the automatic detection device, and it is almost 3.5 to 4 days earlier. Then we looked at the interaction of the prostaglandins with the detection device. As I said, it was a 2x2 factorial design. This is the artificial insemination. This is the embryo transfer. So this is the interaction of cloprostanol and the automatic detection device here. Cloprostanol visual, dinoprost automatic, and dinoprost visual. The same for embryo transfer, and this is pregnancy loss for the same combinations. And there's a lot of data we have and a lot of results, but basically there was no difference. There was no difference in the interaction between the prostaglandin and the way of estrus detection in pregnancy and pregnancy loss. And that is at the end, that is quite an important parameter. And this was for the first service, so the first insemination or first embryo transfer. In the second service, we had the same result, no difference. No difference between the Prostaglandin and the automatic and visual detection device and Dynaprost also for the second service.
Please, Doctor.
Yeah, I'm finishing. The conclusion is automatic detection device versus visual showed an increased hazard to the second service, not to the first service, but we think that is due to the personnel focus. Second, decreased interval.
Sorry,
yeah.
80 times.
Yeah, okay, I'll finish. And an increased hazard of pregnancy. And the two products showed a difference in progesterone and not in estradiol concentration. Reduced the interval to first service, no effect on pregnancy and pregnancy loss, and no impact on the overall reproductive performance and also not on the interaction. So that means that the take home is that the automatic detection devices, they have a good effect. The economics will differ per farm, and the prostaglandin formulations have a small or no impact on reproductive performance. And they should be selected on other parameters than reproductive performance alone. And we are doing follow-up studies to show what parameters they are. For that, thank you for your attention.